Okay, I want to choose one other problem from section 4.5 to look through and to work through, and for you to do it with me. Get the logic down. You might want to shut it off, stop it, and try it yourself first and see what circumstance develop here. But let me work through this now. What we're doing is we've got a limit. We're asked to find the limit of a problem, and this is, I took this from the text. Let me go ahead and set it up onto my iPad and solve the problem there. So what I'm asking you to do here is we're asked to, given this limit, the limit of this function, to identify the indeterminate form, and in the instructions it says 0 over 0 or infinity over infinity, see which kind it is, and then to find the limit. So like I had said before, when you're given a problem like this, you can just kind of go off to the side and let's plug in the 0 and see which form is it going to be. We're told there's an indeterminate form happening here. And in life situations, that won't be the case, but we're setting this up and getting an understanding of how to do it. So let's just plug in the 0. And I'm going to go up here off to the top and just plug in. I get e to the 0 minus 1 minus sine of 0 over 1 minus cosine of 0. And that is equal to 1 minus 1 minus 0 over 1 minus 1. So I get 0 over 0. So yes, I confirm that it is the indeterminate form 0 over 0, which means I can use L'Hopital's rule. That was the purpose of doing it. And now that I've determined that it's a 0 over 0 indeterminate form, let's use L'Hopital's rule, which says that the limit of the original function is equal to the limit of the derivative of the numerator of the derivative of the denominator. So the limit needs to be there. We need the limit. The lim needs to go with it. And then take the derivative of the top and the derivative of the bottom. Derivative of the top, derivative of e to the x is e to the x. Derivative of 1 is 0. Derivative of sine is cos. So it's got a minus sign in front of it, so it's minus cos x over derivative of 1 is 0. Derivative of, I've got a minus sign in front. Derivative of cos is minus sine. So I end up with, this is equal to the limit as x goes to 0 of e to the x minus cos over sine. All right? And when I plug in 0 here, I get e to the 0 minus cosine of 0 over sine of 0, which is 1 minus 1 over 0, which is 0 over 0. So again, I verified that I get an indeterminate form. So I do it again. You still don't get an answer. So, but it is a indeterminate form again. So again, I use L'Hopital's rule. And again, the lim needs to be there. It's a part of the solution. The derivative of e to the x is e to the x minus derivative of cos is negative sine x, and derivative of sine is cos. So I end up with the limit as x goes to 0 of e to the x plus sine x over cos x. Now I plug in 0 again, and I get e to the 0 plus sine of 0 over cos 0. So I can see that cos 0, when I'm looking at it, it's going to be 1. So that means it's going to stop here. So it's either going to be an answer or it's going to be that it doesn't exist, because I get an answer on the bottom. Let's see what we get. So I end up with 1 plus 0 over, oops, you know what I did? Good example, you guys. Lim is needed. I took off lim. Oh no, I plugged in 0, didn't I? I plugged in 0, so I didn't need lim here. That's what that was. Whoops, 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 whoops. Getting excited. Minus sine of 0 over, I plugged in 0 over cos 0. So when I plug in the zeros for the x, I've actually used the lim, so I don't need the lim anymore. So that's what I thought I had forgotten. But the idea is I get 1 on top here. I get 1 plus 0, and the cosine is on the bottom is equal to 1. So we end up with, ready? We end up with e to the 0 is 1 minus plus sine of 0 is 0 over cosine 0 is 1. So I get 1 over 1, which is 1. So the final answer goes back to the original function. Then e to the x minus 1 minus sine x over 1 minus cos x equals 1. All right? That's the idea of section 4.5, using the indeterminate form to determine that we can use L'Hopital's rule, and get the answer to the problem. Okay? Section 4.5, make sure you try it and keep it going. Let me know if you've got any questions.